Today lecture is on smoking of meat and meat products. So in this lecture, there are two parts, part 1 and part 2. The part 1, I'll be talking about how the smoke is formed, what are the different components of smoke, which type of wood we can use for smoking, what are the things you have to follow when you are doing the pyrolysis of the wood so that we can produce a good quality smoke. So basically, how the smoke is generated, if you see, when you burn the wood in the absence of oxygen or in the small concentration of oxygen, then the smoke will be produced. If we burn the wood with the sufficient oxygen, then the flame will be produced. So when the flame is there, smoke will not be much. So our objective is we have to produce the smoke. So let's understand what wood is made up of. Wood is made up of basically three components. One is hemicellulose, cellulose, and lignin. The thermal decomposition or the thermal destructions of these wood components like hemicellulose, cellulose, and lignin is called as pyrolysis. Because of the thermal destructions or the decomposition, more components are released from the hemicellulose, cellulose, and lignin. And if you see, a smoke normally will contain around 300 to 1000 different components. Out of these 300 to 1000 components, some are useful and some are harmful for the human. For example, if you take the phenols, some phenols like guaiac coal, syren coal, such are very useful because they produce the flavor components. Formaldehydes, which has a bactericidal effects. The phenols have bacteriostatic effects. Carbonyl components, which give the color to the smoked meat. On the other hand, if you take the polycyclic aromatic hydrocarbons, which are carcinogenics, which are harmful, which are also mutagenic like. Okay. So some components are useful and some are harmful. So let's understand what is pyrolysis. Pyrolysis means is a thermal decomposition of organic matter. So here the organic matter is the wood we are using in the absence of oxygen or with the limited oxygen. So when the oxygen is not sufficient, when you are burning a wood, it will start producing the smoke. If the oxygen is sufficient, then fire will be produced there and the smoke will be very less. Okay, so our objective is we have to produce smoke because the smoke will contain the flavor components like phenol components and the coloring components like carbonyl compounds. So let's see what is happening when during the pyrolysis. It's normally done in the absence of oxygen or with the very limited oxygens. Pyrolysis will be taking place. So heat will be applied without oxygen. Because of that heat, the pyrolysis will be taking place. So we can see at different temperature, different components are released. So up to 200 degrees centigrade, we can see the water or the moisture that is present in the wood is evaporated. Then 200 to 280 degrees centigrade, we can see the gases and the volatile acids are released. 280 to 500, we can see the pyrolysis of the lignin will taking place, and we can see the wood alcohols and guaiac coal and syren glycol, like such components are released, which will give flavor to the meat products. And above 500, that's normally 500 to 600, 700, like we can see it will be producing the hydrocarbons, that is polycyclic aromatic hydrocarbons. So pyrolysis of the wood can result in the formation of three things. One is solid residues, that is nothing but the charcoal or biochar. So how the charcoal is produced, if you see, means it is also the pyrolysis is done. First, there will be volatile compounds will be released. So when the temperature reaches around 600 or 500 and above or 600 like, all the volatile compounds will be burnt off, and we find the charcoal is formed, which is carbonized, and it forms a cooled. We get a charcoal, which is be containing around 70 to 90% of carbon. Then we have the condensable vapors, that is bio oils, and the tars are formed. The bio oils or the condensable vapors mainly contain the acetic acid, methanol, formaldehyde, phenol, guaiacol, srincol from the lignin, then water vapor, tars, resins, and all these things. Then aromatic compounds. Among this compound that is formed, the condensable vapors, its main important thing is the aromatic compounds, which gives a smoky flavor and the aroma. So that is mainly contributed by the pyrolysis of the lignin, the phenolic compounds like guaiacol, that is 2-methoxyphenol, srincol, that is the 2,6-dimethoxyphenols. So this gives the smoky flavor or aroma to the smoked foods, which is very critical in the meat smoking and barbecuing. Then the non-condensable gases, it includes like carbon monoxide, carbon dioxide, methane, hydrogen, ethylene, and other light hydrocarbons. So when you come to the pyrolysis, that is a thermal decomposition without oxygens or a partial oxygen. It starts around, in the hardwood, it starts around 200 to 250 degrees centigrade. So low temperature pyrolysis, mild range pyrolysis, and the high temperature pyrolysis. So low temperature pyrolysis, normally 200 to 300 degrees centigrades. Here, mainly the pyrolysis of the hemicellulose will be taking place, and there will be a release of water vapor, acetic acids, carbon dioxide, and methanols. Then mild range pyrolysis. This is very important in the case of smoke, in producing the smoke with the good qualities. Okay, so that temperature is range normally 300 to 400 degrees centigrades. So when I say the temperature, it is the temperature of the wood surface. When this wood surface has attained this temperature, the pyrolysis, the mild range pyrolysis will be taking place. So here we can see in this temperature range, mainly the breakdown of cellulose will be taking place and generate combustible gases and smokes like guaiacol, srincol, all from the lignin will be taking place. Then high temperature pyrolysis. So normally it starts around 500 to 600 degrees centigrade. Here the further decomposition of the lignin will be taking place, and there will be a formation of biochar or aviatars, phenols, and other harmful compounds are also formed. So the best temperature as for the smoke, good quality smoke to be produced means the pyrolysis should take place between the range of 300 to 400 degree centigrades. So when you come to the composition of the smoke, what are the factors that will be affecting the composition of the smoke? It depends upon the temperature of combustion, condition of the smoking chamber, how much oxygen is there, oxidative changes in the compounds formed. These all will be affecting the smoke composition. Okay. So let's see what are the characteristics of the good smoke for smoking meat. So a good quality smoke means it should be very thin. Blue smoke is ideal. So the picture that shows here, it should be very thin smoke. It should not be very puffy or it should not be very thick smoke like. Okay, it should be very thin, transparent like with the blue color. That is the best quality smoke which we can use for smoking the meat. So thin blue smoke, the quality is the good. It indicates the clean combustion, rich in flavor compounds, because this will be very rich in flavor compounds. So normally the pyrolysis between 300 to 350 or 400, this type of smokes will be produced. Okay, so this will be low in soot and acids, stars, and other things. Then we have the white smoke, which will be much thicker or opaque. It's a moderate to poor quality smoke. Suggest incomplete combustion. Why it is taking this incomplete combustions? The water vapor or the moisture content will be on the wood will be more. Normally, the ideal is that 15 to 20% should be the moisture. But here, the moisture content may be high. The wood that we are using may not be of good quality. It may be soft wood like. Okay, so what is the problem with this white smoke is that it gives a bitter or the sour taste to the product. So it is also not that much desirable. The best smoke is the thin blue smoke. Then again, what is the other quality we can see of the smoke is that sometimes the smoke may be gray or black in color. This result again of the poor combustions, that is the wet wood. The wood is having more moisture or wet, or it's a green wood like, too much oxygen restrictions. So what's the problem with this black or the gray smoke is that this is very harmful for the when you inhale also. So it contains the soot or the creosote. Creosote is a, a group of compounds or the mixture of compounds we can say which can be harmful to the human. Polycyclic aromatic hydrocarbons. So this smokes again, it is harmful for the human health and bitter because it can cause us cancers, and it is also sometimes said it's a mutagenic also. Okay, so the best quality smoke is the thin blue smoke. So when you're going some places and if you're seeing the smoke, from the smoke quality or the smoke color itself, we can say whether it's a good smoke or the bad smoke. Okay, the good smokes generally we get by pyrolysis in the temperature range of 300 to 400 degree centigrade. So you can see here the puffy white smoke. So this why this is occur is that the fire is not burning hot enough, or the temperature is not hot enough. That may be one reason, because of which the pyrolysis of the wood will not be taking place properly. So this is normally seen when the wood that we are using is wet with high moisture content. So this wood will be containing high water vapor and large smoke particles. So it cannot penetrate the substrate easily, or the food or the meat it cannot penetrate the meat easily. So it also gives a bitter flavor or the harsh taste. Overexposure can mask the natural meat flavors and produce an unpleasant eating experience. Typically, a sign of incomplete combustion or poor fire management. So, if you are not supplying proper heat, or if the oxygen supply is more, of the oxygen supply is less, then this will affect the quality of the smoke. So, we have to select proper wood, the combustion or the proper combustion should be done. If that is not followed, we get puffy white smoke, or sometimes the smoke may be gray or it may be black in color, which is going to affect the quality of the smoke and thereby the quality of the final product. The fire conditions that produce good smoke. See, normally people have the thinks that we can produce the smoke by using the charcoal. No, charcoal does not help in producing the smoke, because already I told you how the charcoal is formed. Charcoal is by heating at high temperature, about 600 degrees centigrade. So at that temperature, all the volatile compounds are already released. So the smoke or the little smokes that comes out of the charcoal cannot give a good flavors. So smoke is actually, this charcoal is actually, it acts as a source for heat. Okay, because it will have very good heat. And once it became glow or a red in color, then we put the wood, especially the hardwood, that wood will undergo the pyrolysis and the flavor smokes will be coming out. So this is what happens in the charcoal. So charcoal directly does not produce, charcoal will act as a source of heat. So wood type is very important. Seasoned wood or the dried wood, hard wood, we have to use it. Okay, any wood which is hard, seasoned wood, the wood that can produce good flavors like apple wood, then oak, such type of wood we have to use. You should never use a soft wood, because soft wood will contain resinous materials which give off flavor. Then the next is the wood moisture. The moisture content in the wood should not be more than 20%. The ideal is 15 to 20%. So avoid using the green wood or a wet wood. Next is the pyrolysis temperature. Already I told the best temperature for the pyrolysis is 300 to 400 degrees centigrade at the wood surface. So how we know it? If you want, when you are doing the research means you can use the infrared thermometers and you can detect the temperature of that. Okay, the optimal for phenol and carbonyl productions. So this temperature, this pyrolysis temperature, where the phenol components and the carbonyl components production is optimum. Okay, then the air flows, the moderate air flows, enough oxygen for smoldering. So smoldering is nothing but we are carrying the pyrolysis in a limited or enough limited oxygen, but too much of oxygen causes flaming combustion. So again, it is not desirable. The smoldering is the temperature around 300 to 400 without flaming. Then it is called as smoldering. Okay, so I understood. I hope you understood what is smoldering. The smoldering is nothing but uh, doing the pyrolysis in the absence of oxygens or with a limited oxygen, but there is no flaming will not be taking place. Then fuel conditions, use wood chunks or the chips. So now in India also this woods are available, wood chips are available. Uh, we can use that wood for the production of the smoke. What to avoid for smoking? What we should avoid? Already we talked about that. The wood that we use should not be green wood. It should not be a soft wood. It should not be a wet wood. Because soft wood, wet wood, green wood all produce the white, puffy, or black smokes it will produce. And the smokes are more acidic and it gives a bitter taste. Then we should not use the softwood, that is resinous softwood. We should not use because they produce certain resins which give a bitter taste to the meat, and it also releases that creosote. Creosote is a mixture of certain chemicals or the tar like things which are not which are harmful for the health also. Then low temperature, too low temperatures. So the excess temperature is not enough means there will be a pyrolysis will be taking place and only the water vapor will be formed and incomplete pyrolysis will be there. The pyrolysis will not be proper. So we should have the temperature around 300 to 400. Excess flame, if excess temperature is there or excess flame is there means high temperature, it will burn off the flavor components. For example, guaiac coal. Okay, so the temperature is more than 400 degree like means it will burn off the flavor components and the flavor that is produced will not be proper, and high flame or the will also leads to production of certain polycyclic aromatic hydrocarbons, so which are harmful for the human. So let's understand the charcoal versus wood for smoking meat. So already I told you the charcoal we use not for producing the smoke, it is a heat source. Wood, when the charcoal start burning or it became red in color, then we have to put the wood. The wood that we use is a hardwood. So this hardwood will be giving the flavor source. Okay. Then smoke production, the clean burns because all the volatile compounds are already pyrolyzed. So we'll get the smoke production will be very minimal and that will be a clean burn, but it will not be having any flavors like. But the wood will be having flavorful smokes. Flavor contributions is mild by the charcoal, strong. Okay, again it depends upon what type of wood you are using. The pyrolysis temperature is very important. Then burning temperature. So already we discussed the charcoal will burn when the charcoal is burning means the temperature is around 600 to 1000 degree. So this pyrolysis or smoldering starts around 250 degree in the hardwood. So the best temperature range is around 300, 350 to 400 degree centigrade because in this temperature range only we get the most flavorful flavor components. If the temperature goes above that, the flavor components will be burned off and it will not be giving the flavor. Combustion characteristics. Charcoal burns clean and hot with a little smoke because Already the pyrolysis has completed the charcoal, so the smoke will not be there. Here the smolders to generate aromatic smokes we can create. Moisture content is very low. So it is mainly the charcoals are mainly made up of carbon. 75 to 90% is the carbon. In a good seasoned wood, the moisture content will be around 15 to 20%. Easy to maintain the steady heat. So it will have high temperature and will be able to maintain that heat. Needs careful management. That's what I told. If the temperature is very low, will not get proper pyrolysis will be partial. It will not be proper. And if high flaming temperature also, it should be avoided because again it produces certain compounds which are harmful, and the color will not get proper color and the flavor. Polycyclic aromatic hydrocarbon risk lower if used alone, higher if wood is burnt improperly. So if you are not burning the wood properly, there is a chance for formation of polycyclic aromatic hydrocarbons, which are carcinogenic. So thick smoke or the soot, the black color that comes, which will containing a lot of polycyclic aromatic hydrocarbon. Common use in smoking is as a base fuel or a heat source in offset smokers or charcoal grills, as flavor additives. So we'll be using the chips or the chunks or the logs of wood is added to the charcoal or the firebox as a flavor additives. So how we know the observation of the smoke and glow? So how we can relate the glow and the smoke? So glowing red but no open flame means smoldering is occurring around 300 to 500 degrees centigrade. Okay, so that is a desirable. 300 to 400 is more desirable. Okay, dense white smoke means low glow. The glow is that red color is not there, and the smoke that is coming out is dense white smoke means the smoldering is not proper or low smoldering is taking place. So it is around 1200 to 300 degrees centigrade, or the wood may be containing high moisture. So partial smoldering is taking place. Thin blue smoke means and glowing edges. So the glowing is very good, and the smoke color is thin blue smoke. This is an optimal smoldering for flavorful smoke. So we get a good quality smoke in this temperature only 300 to 400, and that smoke will be thin blue smoke. Then flaming is there, sparking is there. So the temperature is too high. So it has got into the combustion zone. So more than 500 or 600 degrees centigrade means it is a flaming zone or the sparking, and the temperature will be very high. So it can lead to there will not be much smoke formation, will not be there, and it can lead to the formation of certain polycyclic aromatic hydrocarbons. Now coming to the components of the smokes. The smokes has already we discussed, it's solid, liquid, condensable and non-condensable gases we all see. What are the different components? Okay, it contains the phenols. Phenol is one of the most important components we can say that is favorable for wood smoking, for meat smoking. The phenols properties, if you see it as antioxidant properties, to some extent it gives color also to the smoked meat. It gives a beautiful flavor. Okay, and it has bacteriostatic effect. So phenols are formed by the pyrolysis of the lignin. Next is the alcohol, methanol or the wood alcohol, ethanol, or such type of alcohols are formed. Alcohols are carrier of volatile compounds, and it has small bacteriostatic effect. Then carbonyl compounds. Carbonyl compounds, mainly it gives color to the smoked meat. Then organic acids. Organic acids basically it help in the formation of skin on the surface. Okay, for example, sausage, that surface it has to become hard like. Okay, so that is brought by the organic acids. And hydrocarbons, it is not a desirable components in the smoke, because if hydrocarbons are present, like polycyclic aromatic hydrocarbons, which are harmful, so hydrocarbons is not a desirable. But if you do the smoldering at high temperature range or flaming is taking place, sometimes the hydrocarbons can be formed. So with this background, let's understand why we go for smoking. So smoking is basically done for the smoky flavor, the aroma developments, and the smoky taste. So these are mainly brought by the phenols and the carbonyl compounds. Then we can see the smoked products will have a beautiful color. Okay, that color is another factors why we go for smoking. So this is actually brought by the carbonyls and the aldehydes that is present in the smoke. It also helps to protect from oxidation because the phenols and aldehydes have antioxidant properties. So it helps to prevent the oxidation to a certain extent. So it acts as an antioxidant properties. Surface hardening, it brings surface dehydrations. That is the acids. Okay, the acids that is present in smoke reduce the pH. So pH reduce means the water will comes out of the product and it will be dehydrated. The surface will get dehydrated. Protein coagulations will be taking place on the surface. So the surface became hard. That is what you call as the skin will be formed. Okay, the surface hardening will be there. Then deposition of resinous material resulting from the condensation of formaldehyde and phenol. So formaldehyde and phenols form a resinous matter on the surface. So this act as a physical barrier as well as the chemical barrier against the microbial growth. It prevents the penetration of the microbes into the finished product. So these are the functions, or we can say the primary purpose why we go for smoking. Basically, smoking is done for the smoky flavor and the smoky taste, we can say. Okay, that is why we go for smoking. So what is the side effects of smoking? So we have seen that smoking has many advantages, but if you are not doing the smoking scientifically, it will have a lot of side effects also. First side effect is formation of the harmful compounds like polycyclic aromatic hydrocarbons and heterocyclic amines, HCA and PAH. So this already know that these two compounds are carcinogenic, okay, and mutagenic also. So that is the problem with this thing. And another thing is that many people thinks that smoking is a foolproof method of preventing the bacterial growth. No, that is actually wrong. Because the smoke do not, though smoke has bacteriostatic, bactericidal effect, antioxidant properties, and all these things, the smokes do not penetrate deep into the penetration power of the smoke is not that much deep. So the chance of bacteria to grow in the inner part are there. So we have to maintain proper temperature. So after smoking, we have to keep in the refrigeration temperature, or you can keep it in the freezer or whatever it may be. It depends upon how long you have to store it. So many people think that if you smoke it means you can keep it at the ambient temperature. So it's not like that. So next is the overpowering the meaty flavor. If you do smoking for long durations, if the smoke is of not of good qualities, it will overpower the meaty flavor. And there will be loss of nutrients also. Sometimes if you do prolonged smoking at high temperatures, the loss of vitamins and minerals can take place. Again, smoking, labor intensive, it is a time involvement is more. Sometimes some wood or the smoke components are allergic, and the smokes that is produced will also lead to environmental pollutions. So these are the drawbacks of smoking. Now let's understand components, each components. Phenols, already we discussed this. Phenols are formed by the pyrolysis of the lignin. So it has antioxidant properties. It has developed a beautiful color and the flavor, the smoky taste, guaiacol, coal, the smoky aroma or the flavor it will develop. 4-methyl guaiacol, 2,6-dimethoxyphenol. All this comes under the phenol groups. And this basic function is to give the smoky taste and the smoky aroma, the flavor. And it also has the bacteriostatic effects. So most of the time, the people ask why the smoky taste gets less after a few days or week. See, the phenolic compounds that is formed from the smoke are not stable. They're unstable. So they'll be dissipating after a few weeks or month. So if the temperature where you keep the smoky product is high means most of the flavor will be lost faster. Okay, because higher temperature, the volatile compounds will be lost faster. Then coming to the alcohols. So basically, alcohol does not have much influence on the flavor or color. Its main role is it acts as a carrier of volatile compounds. So the alcohols like methanol or the wood alcohol, it has very minor effects on the bacteria, that is bacteriostatic effect it has. So it has no major roles in flavor developments and aroma. So it is generally considered as a less important classes of components of smoke. So its main function is the carrier of other volatile compounds. Alcohols. So alcohols are formed from the pyrolysis of the hemicellulose and cellulose. So alcohols, these are volatile organic compounds. Sometimes they add sweetness or sharpness to the aroma, but not much influence on the flavor. May act as a precursor for the acids and the aldehyde. So compound contribution is that methanol present in small amount, but toxic if in higher doses. Okay, ethanol, minor contribution to the aroma. Propanol, 1 propanol, 2 propanol, sharp aroma it can produce. Okay, so this is not having much effects, very slight effects. Like alcohols does not play much roles in flavor or color developments. Then coming to the organic acids. Organic acids are formed by the pyrolysis of the hemicellulose. So it has minor preservation actions, the acidity of the surface. Already I told you, organic acids mainly help in the coagulation of the protein and skin formation of the meat. Okay, so it helps in the coagulation of the protein. It reduce the pH will be reduced, water will be lost. So surface drying it can brought and the coagulation of the protein. So it's helped mainly in the skin formations. The acids that are formed from the smokes are formic acid, acetic acid, propionic acid, butyric acid, isobutyric acids. All these acids are formed. So no direct influence on aroma or the flavor. Sometimes these acids give tangy flavors. Then carbonyl compounds. Already I told this mainly help in the color developments. Okay, the smoke flavor, little smoke flavor, and mainly its role is in the color development. So the carbonyl compounds like diacetyl, acetone, propanol, all these things. So the carbonyl compounds like formaldehyde, acetaldehyde, furfuryls. So how they bring the color is that the carboxyl groups of these carbonyl compounds reacts with the amino groups of the meat proteins, and they forms what you call as Maillard reactions will taking place when they are subject to a little high temperature. So this is gives the product golden brown in color. So you can see flavor to some extent. Color is the main brought by this carbonyl compound, the golden brown pigmentation. You can see the chicken. This color is mainly brought out by the carbonyl compounds. Then hydrocarbons. Already I told when you are subjecting to high temperature or the pyrolysis is taking place with very high temperature means then polycyclic aromatic hydrocarbons are formed. A number of polycyclic hydrocarbons have been isolated from the smoked food, out of which at least two of the compounds, like residue of the benzopyrene, especially the hydrocarbons like naphthalene, uh, anthracene, fluoranthracene, pyrene, are all examples of PAH, a class of organic compounds characterized by multiple fused aromatic rings will be there. So as the temperature increases, the number of rings will also be increases. Two things which can causes the cancer is that this polycyclic aromatic hydrocarbon is benza-A-pyrene, dibenz AH anthracenes. As the temperature increases, the number of rings formed may be 3 or 4. So it starts from 2, 3, 4. Okay. So the limit is, as per the regulations, the limit that is allowed is 5 microgram per kg. So the polycyclic aromatic hydrocarbons, maximum level that is allowed is 5 microgram per kg in the smoked meat products. At what temperature do the polycyclic aromatic hydrocarbons are formed? Is maximum. It is C. That's what I told. If the temperature is above 500, the polycyclic aromatic hydrocarbons will be started form. So it is very many research papers shows that there is a sharp rise in polycyclic aromatic hydrocarbons between 520 and 560 degrees centigrade. So around 660, 600 to 660, the peak amount of polycyclic aromatic hydrocarbons are seen. So how to avoid the polycyclic aromatic hydrocarbons? So we can use in the smoked product is that we can use the liquid smoke. We can use the fibrous casings. The synthetic fibrous casing can be used because through the fibrous casings, the smokes cannot enter. So slow cooking for longer period of time. You keep on turning the meat when you're doing the smoking, keep on turning the meat. This help to reduce the surface temperature, and this also help reduce the formation of the PAH. Add complementary consumptions of food rich in fibers and flavonoids. You can do it. Then cooking methods, baking, microwaving, steaming, reduce the polycyclic aromatic hydrocarbons. Avoid charring or blackening. So charring and blackening should be avoided. So if you do too much of charring or blackening, so it should not become, the meat should not become too black in color. The golden brown color is most desirable. Sometimes they make the beef and other things, they make it very black. So that is not actually good for health because it may be contain high content of polycyclic aromatic hydrocarbon. Then you can also marination help to reduce the formation of polycyclic aromatic hydrocarbons because marinades containing herbs, spices, and acidic ingredients can act as a barrier to the formation of polycyclic aromatic hydrocarbons. Fat trimmings. So sometimes we see when we do smoking, the fat will be dripping onto the open flames. That can also lead to increased polycyclic aromatic compound formations. Okay, so fat trimming. So fat should be trimmed off so that the fat drippings will not be taking place much, because when the fat falls directly into the smoke, again there's a more chances for formation of this polycyclic aromatic hydrocarbons. Then cleaning the griller or the smokers, we have to clean it regularly. So the soot or the other things are there, means it should be cleaned off, because when you heat it out, the soots may fall, which will fall into the food materials. So that is also the soots burns, and it also forms the polycyclic aromatic hydrocarbons. So these are the different ways how we can reduce the polycyclic aromatic hydrocarbons. So how the smoke color is formed in the smoked products. Already we discussed this one. So mainly it is the smoke color is mainly brought by the deposition of the smoke component like phenols and the carbonyls. Phenolic compounds, as already told you, guaiacol and silincol. These are aromatic molecules produced during pyrolysis of lignin in the wood. So 300 to 400 degrees centigrade, this pyrolysis will be taking place. They deposit on the surface of the meat and contribute to the smoky flavor and a light brown tint. Carbonyl compounds, already we talked, the formaldehyde, aldehydes, ketones. So the amino group, the carboxyl groups of this carbonyl compounds reacts with the amino groups of the protein on the meat surface. So that leads to a reaction called as Maillard reaction, non-enzymatic reactions, responsible for the golden brown color formation, especially when reacting with the heat. So thank you. This is the end of part 1. In the next part 2, I'll be talking about the standard operating procedures for the smoking. I'll be talking about the cold smoking, hot smoking, then how the smoking should be done, like what are the precautions you have to follow during the smoking. So thank you. Have a nice day.